Hi, we're going to look at graphing quadratics today. Quadratics is going to give us a parabola shaped a U shape graph, and we're going to see where we go with that. Before we do anything, we need to understand what this is and how do we start. So standard form, y equals ax squared plus bx plus c. This is important because this helps tell us where we have certain numbers at in this equation, and we need that to help find the formula for the axis of symmetry, which is x equals negative b over 2a. That's the important part that we need right now. We get the b, we get the a from in front of the x, in front of the x squared. So let's find that. Let's start there and see where we go. So x equals negative b over 2a. My b value, in this case, is 4, so I'm going to have my original negative from the formula, then my 4, 2 times a in front of the x squared. We don't have a number, so it's that magic one that hides out. So when we simplify, you end up with negative 2. Now this answer, we go into our t-chart right in the middle because we just found the axis of symmetry, x equals negative 2. We found the axis of symmetry. That's in the middle of our graph. We want it in the middle of our t-chart. Now we need to find numbers smaller, numbers larger. So smaller numbers, negative 3, negative 4, larger, negative 1, and 0. So we have x values. We created half that table. We now need to find our matching pairs for the y half. What we're going to do is take each one of these x values, substitute them back into the original problem up here. So let's substitute them in and see where we go. Negative 4 squared plus 4 negative 4 plus 3 gives us negative 4 is 16 minus 16 plus 3. We end up with 3. Do it again, this time with negative 3. Negative 3 squared plus 4, negative 3 and 3. So 9 minus 12. 12 minus 12. So 0. Do it again, this time with negative 2. Now, each time I take one of my numbers that I substitute in, I put them in parentheses. This way I don't confuse myself with the exponents and the negatives and all that. 4 minus 8 and 3, which gives us negative 1. Now, I'm going to stop there because even though I only did 3 of these, I could keep going. But since we have an axis of symmetry, we have the middle of our graph, and I'm going to graph those first 3 points. Back 4, up 3, back 3 and 0, back 2, down 1. So what we have going on, we have that axis of symmetry down the middle. Remember, this kind of folds and they match up with each other. So if I'm one spot away over here, I got to be one spot away over here. So these numbers end up mirroring each other. So I go 0, 3, and watch how they mirror. So back 1, up 0, over 0, up 3. We end up mirroring ourselves. So you don't have to go through and do all 5. We definitely need to do the vertex. Then you pick 2 or 2, whatever is easier for you to do. Substitute, simplify. Okay, you have your parabola. You have that. Now we need to figure out what's all the important information. We need to figure out all of this. So axis of symmetry, very first thing we found, x equals, always an equation. X equals negative 2. The vertex is always half of the axis of symmetry. So it's going to be a coordinate, negative 2 comma something, in this case, negative 1. Y-intercept, where do we cross the y-axis? Always going to be we can put it either as y-intercept equals 3, or I'm going to do as a coordinate, left and right 0, up 3. So 0, 3, the coordinate will always have a 0 in it. Max or min. So this graph forever goes up, it never stops, but it does have a lowest possible point. It has a minimum, a low point. We have a min and that lowest possible value that it goes. Now we're talking about y is -1. And remember, look, check that out. It goes right back to the vertex. We have how many solutions? Well, we cross the x-axis once, twice, 2 solutions, and those 2 solutions are x equals -1, even though I'm sloppy, and x equals 1 to -3. Domain and range. Domain is our x values. Now this parabola, it goes up forever, but it also goes outwards very slowly, but outwards forever. So since it goes out, I'm going to hit every number going that way. I'm going to hit every number going this way eventually. So we say our domain is all real numbers, every number ever, or this fancy little r. My range, we're talking about y values. Always going back to the vertex, what's the lowest or highest point? We hit -1 in this case. Because we hit it, we have to have an equal sign. And do we go above -1 or below -1? In this case, everything's up, so we're talking about greater. So we put a greater than sign there. And that is graphing quadratics.